The Ermac Centre is proud to present the SFU Fellows of the Royal Society of Canada Seminar Series. This bi-weekly series hosts 5 presentations per semester. For the spring 2013 semester, the presenters belong to the Departments of Economics, Physics, Humanities, and the Faculty of Education. Today's speaker is Dr. Arthur Robson from the Department of Economics.
Well, it's a pleasure to introduce Arthur to this talk. Arthur holds the Canada Research Chair in Economic Theory and Evolution in the Department of Economics. And yesterday, in order to prepare for this introduction, I looked at the papers that we prepared for his nomination for the Royal Society, and I'm just going to read the first paragraph that we wrote at the time. Arthur Robson is an outstanding scholar who is building bridges between economics and the disciplines of biology, archaeology, and anthropology. His path-breaking research focuses on the origins of preferences, evolutionary psychology, and implication for economic behavior. Arthur Robson's fundamental research inquiry is what we can learn about human preferences and economic behavior by using the fact that we are the product of natural selection. Underlying Arthur Robson's research is a central theme that man is not the rational self-interest decision maker as captured by classical economic theory, but rather a product of evolution. As a result of his research, Arthur Robson is internationally recognized as a top economist in evolutionary economics, as a leading economic theorist in Canada, and as a major contributor to Canada research reputation in economics. At SFU, Arthur is also one of 7 co-investigators in the CTEF project, Human Evolutionary Studies program. Last year, he received a Guggenheim Fellowship, allowing him to split his time between Yale and UC San Diego. He's just coming back from a mini course at the University of Toulouse, and he may be on his way to another one at NYU. So we are very happy to have him today. Please welcome Arthur.
Thank you very much. So for more than the last 20 years, I have been entertaining myself as an economist by thinking about the biological foundation of economics, which has made me feel like the window at the lower left. More recently, I've noticed that some of the other windows have tilted a little bit, and some of them even in the same direction as me. One of the windows whose tilt matches mine to some extent is that of my co-author on this paper, who is Luis Rao of the London School of Economics. We want to think about what accounts for the arguments of utility functions. What explains what it is that we value and how much. The big question that we have in mind here is, what are utility functions for? This is the question that Daniel Dennett, in his book, Darwin's Dangerous Idea, pushed eloquently. If you want to understand something, some adaptation in the world, ask what it's for, what it does. The smaller question, more precise question that we want to ask, though, is why do utility functions depend on the things that they seem to depend upon? And in particular, why do we care about anything other than offspring? If we are the rational and intelligent agents that economists like to think that we are, although we may be flattering ourselves quite a lot to think that, suppose we are, just for the sake of a working hypothesis. Why is it not the case that nature would have said to us, all you care about is offspring? You should figure out that if you want to have offspring, you're going to need to stay alive. And if you want to stay alive, you better eat. You should figure out that if you want to have offspring, you should have sex. It's not going to be any particular fun, but it's something that we'll have to be born with for the sake of the consequences. You're going to need to stay warm, and so on. It certainly does seem that we care about other things intrinsically. That is, we'd be willing to sacrifice expected offspring for the sake of an increase in some of these other intrinsically valued commodities. The best prima facie evidence for that, perhaps, is the demographic transition that took place in Europe in the 19th century and is continuing to this day in some parts of the world, whereby there was a big run-up in income, but the number of offspring fell. So it certainly seems on the face of it that we spent the money on something else. How is this consistent with an evolutionary basis for utility? This is the question that we want to entertain ourselves with. We're going to argue that the marginal utility of something that you do is going to reflect informational asymmetries between you and Mother Nature, to speak somewhat dangerously anthropomorphically of Mother Nature. And it doesn't derive, and it's not simply the instrumental effect that this action has on expected fitness. It doesn't matter much, but we have in mind that there are a number of innate arguments. When we say innate, there are some arguments that are conditioned. A psychologist, Linden, in the book The Compass of Pleasure, lists a bunch of candidates for innate arguments of utility: food, prestige, body temperature, the view, sex, effort perhaps with a minus sign. Jeremy Bentham lists 26 categories of simple pleasures and pains. I think 14 of the former and 12 of the latter. Not everything he says is simple seems obviously innate. He nominates money as a simple pleasure, and when he explains why is money a simple pleasure, well, it's because you can spend it on stuff, which seems to qualify it as conditioned rather than innate. There are lots of conditioned arguments too, and perhaps the most obvious one, if you're an economist, is money. It used to be that fMRI jocks thought that you couldn't distinguish the fMRI signature of money from sex. Now they think you can. Here's a guy in France who figured this out. But money and sex do have slightly different fMRI signatures. You can only speculate what exactly they were doing in these laboratory experiments. Must have been a lot of fun for all involved, I guess. And that the difference between money and sex is a difference that captures the instrumental role of money versus the primary role of sex, they claim. So the general problem we're going to think of as what economists call a principal-agent problem. So a prototypical principal-agent problem would be the owner of a firm on the one hand, and the CEO on the other. The owner gets all of the expected profits, taking out whatever's paid to the CEO. The CEO knows a bunch of stuff about what's going on with the firm that the owner or the principal doesn't know. And the principal, the owner, would like to design a contract for the CEO that induces it's also true that the CEO does things that are not directly observable by the owner. He doesn't know if the CEO is working hard, for example. So what the owner would like to do is to design a contract that maps observed outcomes for the firm into money outcomes for the agent, and that induces the agent to work as hard as possible given all the constraints, and to come as close, more precisely, to maximizing expected profits for the firm as it's possible. We want to think of that story as applying here, where the principal is going to be Mother Nature and where the agent is going to be the individual. So we're going to think of nature as designing the utility function for the individual. We're going to think the individual, and for that matter, nature, see two signals. One of these represents stuff that can be put into the utility function, and the other represents stuff that can't. First bunch of stuff could be stuff that it has recurred a lot over evolutionary history. So it's always been true that staying warm is a good idea. It's always been true that if you want to have offspring, you should have sex, and so on. So these are the things that can be put in to your utility function. The recurrent nature makes this possible. The individual, though, is going to take the utility function that's handed down to him by Mother Nature and maximize his little heart out. But he has very weird beliefs, arbitrary beliefs about what the signals that he sees means. He might have grossly deficient beliefs about what eating means, about what sex means, about what staying warm means, and so on. So the agent maximizes utility, takes an action, and then it's pretty much game over. This determines fitness, and the rewards are obtained by the Mother Nature in terms of fitness, and by the agent in terms of utility. And the key question is it possible for nature to design the utility function so that the individual chooses the best action, conditional on all of the information, taking into account the best possible information? And the answer is going to be yes, at least under the conditions that we're going to suggest. So there's the principal agent problem. The Svengali-looking character being the principal, the somewhat diminutive marionette at the bottom being the agent. This is a little unkind to the agent. It's very unkind to the agent. Pretty unkind to the principal too, I suppose. It's unkind, though, to the agent in the sense that the story that we're telling relies on full autonomy on the part of the agent. You have a utility function that you don't have any say in. It was handed to you by Mother Nature, but then you can do your utmost to maximize that. Maximize, in fact, the expectation of that, taking into account anything you like, anything that's relevant. And that combined system of some rigidity, the utility function being designed by nature, and total plasticity, given that utility function on the part of the agent, we're arguing is optimal, is overall optimal. It's a system that allows both recurrent information and evanescent information, idiosyncratic current information, to be taken full advantage of. So a simple story is that nature knows that high protein food is, with apologies to vegetarians, I should say, nature knows that high protein food is good for fitness. You know that there are GNU-like ancestors to the northwest on the African plain. Mother Nature gives you a taste for meat. With trying to maximize the utility that depends on an appreciation for the taste of GNU-like ancestors, and knowing where to find them leads to a good outcome overall. The best, at least in the model. So let's get this So for the people who are economists, this is a little bit different than the standard principal-agent problem. The Oldsmobile used to have an ad that said, this is not your father's Oldsmobile, which I think was a way of trying to disguise the fact that it was, in fact, your father's Oldsmobile, a really boring car. This is really not, though, your father's principal-agent problem. So all the actions are contractible, meaning, or they're not hidden in any way. There's no problem that the principal in the prototypical economic story would have in observing what whether the CEO is working hard or not. That's not an issue. It sounds like there's a huge difference in that you're designing the preferences of the agent, but if you think about that a little harder, if you have the full flexibility to design how the outcomes for the firm map into money outcomes for the CEO, it's not so different in the end from designing the utility function for the CEO. But the one thing that is really weird about this from an economic point of view is that the principal has information that would be in her interest and in the interest of the agent to transmit, but somehow she can't transmit it directly. So here's a little model. When I last gave a talk like this, I took out all the math, but I feel a little dishonest taking out all the math. There's math. I'm going to bare my teeth and reveal some of the math. It's not such hard math, actually, as economics goes, in any case. So there's a state sigma, which is the number. There's two signals, S and T, which are also numbers. S represents things that are recurrent, so they're candidates, so that this can be put into the utility function. And T represents stuff that is evanescent, and so can't. The true distribution of the state is given by this distribution. The state is sigma, so this is a PDF. It's little f. The weird beliefs, the arbitrary beliefs of the individual are given by some different PDF G. The agent takes some action X, which could be an Rn. And Y is fitness. Y depends on some function phi of X and sigma. So let's, just for the sake of having something specific to talk about, get a little bit ahead of ourselves and define X star of S and T as the best possible action to be taken when you have the signal combo ST. We haven't said enough to make this really be exist or be unique or anything, but we will eventually. Let's not fuss about that. So the principal chooses utility function that's going to map X, the action, Y, which is fertility or expected offspring, and S into R. The state is drawn, the agent is given you, observes S and T, and solves the problem of maximizing expected utility given the crazy beliefs given by G of utility given S and T. And fitness is produced, and the question is, how can nature implement X star? Or is it possible? And the answer is yes, it can. And at least on the conditions that we're going to have. We're saying that if you have the ability to warp the utility function of the other guy, of the agent, you can warp it in a way that compensates for any weirdness in the beliefs that this other guy has. So just to be a little less anthropomorphic for a minute, what we mean is that evolution shapes utility functions in the light of recurrent considerations. So individuals who like to be warm have better survival rates than those who don't. There's also lots of novelty, and it's a good idea to be able to exploit that. So you want a degree of autonomy. This is just a story that we had before. In terms of a metaphor that Ken Binmore came up with, you want the individual to act as the eyes of evolution, to see local circumstances. So the bottom line is just that if you like warmth, you're going to look for it, you're going to figure out where it is, how to get it, in terms of all kinds of local idiosyncratic goings-on. So nature knows that exposure to the sun leads to the production of vitamin D. Vitamin D, it's always been a vitamin, so it's always been appreciated. It's a good thing to have, a little of at least, but it's only recently been appreciated just how fantastic it is. If it does even half the things that it's claimed to do, everybody who lives in Vancouver should take it for sure, given the absence of sun. But how does nature address this? Nature doesn't tell you that vitamin D that sitting in the sun makes vitamin D, and vitamin D does this whole string of things. This was only recently established in terms of modern science. What nature does is tell you it feels good to sit in the sun. It could be that the acids that we're talking about are invariant, or they're always true, or they could be a little bit more complicated. They could be circumstances that vary. So it's a good idea if you're warm to drink cold things, and if you're and vice versa. And this in fact shows up in what drinks taste like. If you're cold, a hot drink tastes good. If you're and vice versa. And this is something that the neurological basis for, which is pretty well understood, is described in this book by Kandel. So this is in some sense is an S that's varying, but it's an S that you're either hot or you're cold. But being hot is something that's happened a lot over evolutionary history, and being cold is something that's happened a lot over evolutionary history. So what are the options here? Well, it could be that G is F. But if G is F, this is ridiculous. Then you just want to set utility equal to Y. Y is just fitness, phi of X sigma. So the agent's problem would be this. But this is just nature's problem. So there's no issue. If the beliefs of the agent are the same as the true story captured in F. But this just doesn't seem true. It's not true, that is. I won't ask for a show of hands, but it's not true for most people that all we care about is offspring and that we have no intrinsic interest in sex. I mean, it might be, sometimes it's claimed that there's no evolution occurring in modern populations, which seems a rather premature conclusion. A good guess for something that might be evolving would be that an interest in having offspring, given the access to contraception, or considering a population where that's true, then, and supposing that an interest in having offspring is in any degree heritable, then you'd expect that there should be more and more people in the population. The people who don't want to have offspring, those lines are going to die out, and the lines that are going to survive are the ones that do. So but this is saying that we're moving in the direction of this. We're moving in the direction of maximizing simply Y. So it might happen, there could be some evolution in this direction. It could be that with our intelligence, with the social provision of knowledge, that this would become a much more reliable way to do things than it would have been in the past. But it certainly doesn't seem true now. Here's a little story. I hope you understand that I'm a shy person who finds talking about these things distressing. But here's a little story. It was always known that you take, if you look at mice, and they're looking for a romantic partner, they do a lot of sniffing. And they can establish that actually what they're picking up on is difference in the immune system of potential partners. Difference, to be precise, in MHC. It's a good idea. So MHC gives you is present in mammals in general. It gives you immunity to a small suite of diseases, or step up in terms of immunity to a small suite of diseases, maybe 100 or so. And given that rather small number, it's a good idea to pick a romantic partner who has somewhat a different deck of cards than you do, because your offspring will have immunity to more diseases if you do that. And that's what mice are doing. They're picking up the smell, the signature of a different MHC than their own, and going for that. So someone thought to do this on humans, and here's what happened. You have a bunch of guys wear T-shirts for a while, and get them sweaty, put them in boxes, and then have women smell the boxes and tell you which one smells the most pleasant, or perhaps least unpleasant. And it turns out that the women tend, at least the claim is, women rank T-shirts worn by men with compatible, meaning different immune systems, different MHC, as more pleasant or less unpleasant than the other possibility. This is something, supposing this is true, this is something that, supposing it holds up, then this is something that we're not born understanding our own immune system, let alone how to detect somebody else's, let alone why it would be a good idea to pick a different one or any of that. That would be what we would have to be doing if we were maximizing Y. If F was equal to G, we'd have to understand all that. So the right mates just smell good, and they produce a whispering within you, a whispering that you might not really understand the source of, I guess. Most people wouldn't, I think, be able to describe how somebody else smelt very precisely. There's some urge to choose an appropriate romantic partner. This is analogous to putting X into utility. So what we're going to show is that even in that case, when you don't know everything, or you have rather arbitrary, weird beliefs, it's still possible to change your utility in a way that compensates for these weird beliefs and gets a good outcome. We think of this story as applying, not now, but in hunter-gatherer times, so before 10,000 years ago. So from a math point of view, what we want, this thing here is expected fitness. This is what nature cares about. And what we'd like is to allow you to have any weird beliefs here, G, instead of F. But find a utility function that will plug in here that can depend on S, but not on T, in such a way that these criteria match. At least that would be sufficient. This is as a math problem. This is a problem for mathematical physics, freedom equation of the first kind, and the existence of solutions to such an equation is a delicate problem. If we just backed off a bit, it's not so delicate. Suppose we said that sigma and t are both restricted to have a finite number of outcomes, say 1 through big S. So replacing the integral signs by summations, we have this story instead. Which we have all of this stuff is exogenous, is fixed by the problem, so it doesn't really matter. The exact detailed description of it doesn't matter so much. G is also given, and U is what we want to find. So we want to solve this. We want to solve this matrix equation for U. Well, U is a vector. G is a square matrix. You can solve it if you can invert G. And this is a condition that's going to hold, except accidentally. Except that is, loosely speaking, it may fail with probability 0 to hold. So one possibility would be to go down this discrete path, but just for stylistic reasons, we don't want to do that. And in any event, more importantly, what we want to do is, if we got a guarantee of existence of U in the general case, it wouldn't be very interesting without knowing something about its properties. So we'd like to put some more structure on the problem. So the important thing is to put more structure on the problem for that reason. As a byproduct, though, we're going to be able to construct a utility function, and so we're going to get existence. And it's something that what we were talking about originally, making the two criteria exactly the same everywhere is unnecessarily strong. All we need is that X star ST should be what maximizes expected utility. What expected utility does away from X stars that can happen is not important, and couldn't be, for that matter, selected for, because these just simply don't happen. So if you can show that if you can make this work for X star, if you can make expected utility be maximized by X star, that's enough. So, and that's what we're going to do. That's helpful. Okay, so we're going to put a little bit of extra structure on the problem. We're going to say that the distribution F, so in math economist lingo, is first order, it increases in terms of first order stochastic dominance if you increase S. So if you increase S, all we mean is that you make the distribution F unambiguously better. You could shift it bodily to the right, to higher outcomes, for example. And similarly, if you increase T, you shift the distribution of outcomes bodily to the right. We're going to assume that fitness is concave in X, so it's curling over, it's increasing, or not always increasing, but it's initially increasing, reaches a peak, then goes down, it's curling over, it's concave. We need to assume some additional things about cross products. That is that if you increase sigma, it increases the marginal product of each xi, the derivative with respect to each xi. And that the cross products with respect to different xi and xj should be positive or non-negative. So it follows that each x star is increasing in S and increasing in T. It's really a very simple problem. The multiple dimensions of X, we've kind of tricked ourselves around the difficulties that might create with these assumptions. Made it a lot simpler than it looks, than it could be. So if there were two x's, the picture x1 and x2, just fix, say, S and vary T, the locus of x star is something that looks like that as t varies. As t increases, you move along this, going along this way. So we're going to, let me just give you the main result. So to do that, we have to talk about two new functions in 2 dimensions, or a bunch of new functions in more dimensions. So let's just go back to the picture. Suppose there are 2 dimensions. I want to define a T1. So T1 should be defined for any x. So pick an x here, for example. Then T1 of x1 and s should be the value of t that you need on this to be on this locus and generate the same value of x1. And similarly for x2. You're here, so t2 of x2 and s would be the value of t that you need to have in order to get the same value of x2, or it would be the t value right there. So there's the result. There's a utility function that will work. There's no claim about uniqueness. This is just a utility function that will do it. It's a utility function that is offspring, phi, plus a term alpha. A term alpha that depends on x and s. It's a term that, it's an additive term. It's added on. It's also additive in terms of its own structure. It's something that depends on, is a function of x1 through however many x's there were. But alpha x and s will be the sum of alpha i's, where each alpha I depends only on xi. And there's an explicit form for alpha I. So what this is saying is that it's not very complicated, really. It's saying that in order to get you to do the right thing, you're inclined to do the wrong thing. If you were just given fitness and you had your weird beliefs, you would do the wrong thing. You would pick the wrong x. A bunch of wrong x's. So what do I need to do? I just need to, I need to attach an extra term that depends on each x. I need to attach a term that encourages you to go further if you're inclined to stay short, and encourages you to pull back if you've already gone too far. And I'm going to do that for each xi. Okay. So it's not unique. It's not unique in lots of ways. There's no claim that it's unique even in its own terms. But one way it's not unique is that we're saying that phi is a function of x, and then we're adding some other terms in x. So from a mathematical point of view, to say that that's y plus terms in x is a little arbitrary. You could say that's all just a function of x. You could say, you could take half the y and call that a dependence on y, and take the other stuff as being a dependence on x. So, but one thing it generally can't be is just y. Y by itself is not going to work. As long as those alpha terms are encouraging you to do something different, then those terms are not, then y by itself is not going to be a good utility function. So here's an example. So it's as simple as it possibly could be. Suppose that fitness is quadratic. We want it to be concave, so it should have a minus sign in front. X minus sigma squared with a minus sign. So we also want to assume that the signal is all over the place. It's easy to do that. That's all that's really trying to say. and that nature and gets some signal about sigma, and you get some signal gets two signals about sigma, S and T, and you get to you see S and T, but you have different those signals that have different noise. So it follows that the true mean conditional on S and T is lambda S plus 1 minus lambda T, where lambda is this thing. This has to do with the relative precision of S and T of these signals. X star would be the mean. So it would be that. For the individual, it's a similar story, but the individual has weird beliefs represented by, or weird beliefs in these terms, meaning noisier signals about S and T. It's the same kind of construction, exactly the same construction. It's going to be gamma S plus 1 minus gamma T, where gamma is equal to the ratio of the precision of the signal for S to the signal, to the combined precisions in the bottom. And it's the same way that X star was this, X hat will be this. So you can figure out exactly what the utility function should be. It should be that. It should be y, that's offspring, plus an additional term that depends on the difference between lambda and gamma. So if this is just does exactly what you'd expect, if lambda is greater than gamma, then the individual is putting too low a weight on S, and the Mother Nature would like you to encourage you to put more weight on S. And so if lambda is greater than gamma, there's a penalty for choosing an X that's different from S. If it's the other way around, if gamma is greater than lambda, then you like choosing an X that's different than S, and you're going to move away. Okay, so this would apply to, for example, perhaps, the relative precisions might apply to, say, polar bears and rivers. Over this last summer, I walked across Baffin Island, and there's two hazards that strike you. One of them much more acutely, psychologically, than the other. And the one that strikes you much more acutely is polar bears. The one that's actually more of a risk, but doesn't bother you much, is rivers. So we could think of it in these terms as nature's signals about bears are just unambiguously dangerous. And nature has very precise information about this. And you should be, it should take a lot of sweet talk from your hiking companion to get you to creep up behind that polar bear and go boo, or pat it on the head. You're programmed in general to avoid large predators that have sharp yellow fangs and claws. Whereas river crossings certainly can be dangerous, but it would be very inconvenient to program you to avoid rivers because they have lots of uses as well. So the local information T is now important. I didn't take their picture, I'm happy to say. I did take that one. This is a river crossing. This is the guide on the trip, and he thought that this crossing was not good for us, but I think he could have gotten across, but he didn't think we could. So this is what a marginal crossing looks like. We had to, because we couldn't cross here, we had to walk all the way back down into this valley, back down the river to the left, find a place to cross it, come back up here. Took 24 hours to come back to just the other side of the river. Oops, so let's do this. So I hit a conclusion. Why is utility not just offspring? And the resolution we're proposing is that utility is a whispering within, in terms of a book by Barash, urging individuals to take actions that reflect the evolutionary wisdom of a multitude of ancestors. And the loudness of the whisper, and the examples anyway, depends on the relative precision of the signals. How hard you're being urged to do. So there'll be the polar bears versus the rivers. There's a very loud whisper in your ear to avoid polar bears. It's not very convincing about rivers. There are other ways of getting to the same place. It could be that nature would somehow have made sure that you understood all of this information. And it might be that the reason that we are where we are in terms of utility functions is to some extent phylogenetic happenstance or accident. Could it be that it's important in order to understand this, that we understand that we evolved out of creatures that aren't quite as gloriously intelligent and rational as we like to imagine we are? But the fact that you can get to the same place to the first best outcome would mean that there would have been decreased selection pressure to do something different. Okay. And there's a final picture from Baffin Island.
So it's time for questions. Since we are recording this, please use a mic when you post a question.
Right.
Great talk. Thank you. So you've shown us that if we have crazy beliefs, nature can compensate for that in evolutionary time. I wonder if you could say something more about the source of the crazy beliefs, and if crazy beliefs change rapidly, perhaps for cultural reasons, would nature be able to catch up with the changes in the crazy beliefs?
I think the answer to the last question is no, which kind of answers the first one too. I don't see how. So it has to be with crazy beliefs means sort of systemically long-run crazy, but not time-varying beliefs.
Do you have any thought about where the systematic crazy beliefs come from?
Well, I wouldn't. So it's not. So we're modeling it as crazy beliefs, but think of it. It's really ignorance that was the motivation that we started with. It's that you don't know that you don't know that sitting in the sun produces vitamin D. That vitamin D does the whole list of things it's currently supposed to do for your health. You don't know that, so that's what we really mean. Or you don't know all the stuff about sniffing T-shirts either.
Lack of knowledge about causal connections.
Yes, yes. But we're thinking of it as you get the signal, but you don't understand the implication, the statistical implication. But we originally modeled as you just didn't get the signal, right? You just didn't understand that. What was going on?
Yeah, the sources of information on the number 3, it looks a lot to forward, sorry. It looked a lot, you were talking about local information and forward. keep forward. What's the conclusions?
On the conclusion.
There we go, number 2.
All right.
So you have the whisperings within and then the local on-the-spot information. Does that correspond pretty much to what biologists would call instinctive and learned? And then how would you, if so, or even if not, how and why?
The first one would be, in the utility function, would be pretty close to instinctive. Yeah. I mean, I guess when you think about humans, it's easy to imagine. I don't know, you know better than I would about research about this, but it seems that there's a spectrum of urges, of impulses. That is, some things nature is telling you in very strong terms, don't do it, don't even think of it, right? Don't put your hand in the fire, don't jump off a 10-story window ledge, and so on. Other things, she's telling you, not a good idea, but if there's some compelling reason, go ahead. And things where, think about it, might be good, might be bad. So that would be instinctive. And learned, we're not really accommodating very well. But well, so we're thinking of agents here as we're allowing them to be, with some hubris, very intelligent and rational in the sense of economics. So we're not going to need naive learning in order to figure out something out. We're going to figure it out using Bayes' theorem. It could be that if you wanted, it probably wouldn't be much different to say we're not such. We don't do this at such lightning speed. We actually take a little while to figure it out and get to the same place in the end. Yeah, it's pretty close. It's pretty close. It's pretty close. Yeah.
Do you think it relates to Kahneman's type 1 and type 2 systems at all? The automatic system and then the more...
Yes, it does, I guess.
Thank you very much for the interesting ideas in your lectures, and excuse this question if it's a little based on evolutionary ignorance. But what I wanted to ask was, suppose you look at arbitrary belief versus utility function. So the arbitrary belief comes from ignorance and would come from some religious situation where perhaps the hunter-gatherer is very frightened of thunder, say, makes the thunder, personalizes the thunder into a person, and eventually it seems to me that once the religious belief is more formal, it could enter into the utility function. For example, you could start at a much later stage, for example, saying, well, you can't just smell somebody to think he or she is good to marry, but you have to marry so-and-so and so-and-so. So it seems to me the arbitrary belief could enter the utility function and distinctly change the course of the human.
Yeah, it's complicated, I guess.
But it's an important consideration because it seems to me that it would really change the nature and change the nature of everything. And it would, in some sense, damage one's natural instincts. It would come from, say, the whispering within.
So I mean, if this took place rapidly, say in the last 10,000 years, then there wouldn't be any time for natural selection to bear on this, and I wouldn't
overtake natural selection.
And there's no reason to be, or leave it to the anthropologists to tell us what that would mean.
Let us thanks to our speaker again. Thank you, Arthur. And I would like to